We're going to look at the examples for 5.1 now. So secant u is equal to negative 3 over 2, and the tangent of u is greater than 0. And so we're going to find the following trig ratios using our trig identities. So we're going to do some manipulation to figure out what each of the trig identities, or what each of the trig ratios are. Okay, so first off, I am going to figure out what cosine u is. So using the what property or what identity, how could I find the cosine of u? Well, I know that secant and cosine are reciprocals. So the cosine of u is equal to 1 over the secant of u. So in other words, if secant of u is equal to negative 3 over 2, cosine of u is equal to negative 2 over 3. Now we're going to figure out, using the Pythagorean identities, how to find the sine of u. I know that I have the cosine of u, so I'm going to do sine squared u plus cosine squared u is equal to 1. Okay, so let's replace cosine. I'm trying to find sine squared sine, so we're going to put sine squared u plus negative 2 over 3 squared is equal to 1. So now I have, let's see, sine squared u plus 4 over 9 is equal to 1. Let's subtract our 4/9. Okay, so sine squared u is equal to, let's see, this is 9 over 9 minus 4 over 9, which is 5 over 9. And then we need to square root. So I get the sine of u is equal to root 5 over root 9, which is root 5 over 3. Now, actually, this is plus or minus, so we have to decide which quadrant these functions are in. So let's see. It looks like my cosine is negative. What quadrants are cosine negative? I would say that one and that one, so 2 and 3. And then my tangent is greater than 0, so tangent is greater than 0 in quadrants 1 and quadrants 3. So it looks like my triangle is something like this. Okay, so would the sine be positive or negative? Well, it'd be positive. So this is equal to negative root 5 over 3. Okay, lastly, we're going to use some property to figure out the tangent of u. So how could we rewrite tangent? Remember, it's sine over cosine. That's the sine u over cosine u. And this is the quotient property, or quotient identity. Okay, so sine u over cosine u, that would be sine we just figured out is negative root 5 over 3 divided by cosine we had before, negative 2 over 3, multiplied by the reciprocal. So negative root 5 over 3 times 3 over negative 2, cancel, cancel, gives me root 5 over 2, positive. I hope it's positive because that's what my my given information told me. Okay. Next, we're going to simplify the sine of x times cosecant x minus sine x. So sometimes it's, when we're dealing with trig identities, we just have to think about this as like, a normal equation. This is kind of, let's replace this with a, b, and then sine and sine is the same, so a. How would we multiply those? Oh yeah, we would totally distribute. So we're going to distribute the sine of x into both of these. So this is the sine of x times the cosecant of x minus the sine squared x. Now, I can't do much with this cosecant, so what's something I can replace with the cosecant? Distribute. Okay. What can I replace the cosecant of x with? Well, using the reciprocal property or identity, I know that cosecant of x is 1 over the sine of x minus sine squared x. And then, boom, these cancel and I get 1 minus sine squared x. And I'm like, whoa, Pythagorean identity. Look at your Pythagorean identities. What is 1 minus sine squared x equal to? Oh yes, it is cosine squared x. And I am done. That looks way better than that. Okay, that's it. That's what we're doing, rewriting. Let's do one more. So sometimes the directions say to verify the identity algebraically. Actually, this one is not the same. There it is. Okay, verify the identity algebraically. So what I'm going to do is look at the more complicated side, which is this guy, and I'm going to start manipulating it to get to the cotangent of theta. What I don't know really is if they are equal. So I can't multiply anything by both sides or anything like that. I can only work on one side at a time to make sure that in the end I'm going to get the cotangent of theta. Okay, so this looks like two binomials. So I'm going to FOIL this. I'm just going to multiply it out. Okay, so I get the secant of theta times the cosecant of theta plus secant theta, and then we'll do these, okay, minus tangent theta cosecant theta minus tangent theta, and we're hoping that equals cotangent theta in the end. Okay, one side at a time. So a good trick is to get everything in terms of sine and cosine. So using my quotient identities, I can rewrite this. This would be 1 over cosine theta times 1 over sine theta plus 1 over cosine theta minus sine theta over cosine theta times 1 over sine theta minus sine theta over cosine theta. And in the end, we're hoping it equals cotangent theta. Okay? So I'm looking at this and I'm like, ooh, are there any like terms? What can I do here? Okay, so be like 1. This is 1 over cosine theta sine theta plus 1 over cosine theta minus sine theta over cosine theta sine theta minus sine theta over cosine theta equals cotangent theta. How do you add fractions, y'all? I think we need a common denominator. Okay, so it looks like a common denominator would be sine theta cosine theta. So I'm going to multiply the top and bottom of this fraction by sine theta and the top and bottom of this fraction by sine theta. So I get, everything is going to be over sine theta, so I get 1 plus sine theta. This guy doesn't change, so minus sine theta minus sine squared theta all over cosine theta times sine theta is equal to cotangent theta. Looks like the sine thetas are going to cancel. And I get this 1 minus sine squared theta, which I remember is cosine squared theta, all over cosine squared theta sine theta. And we're hoping this equals cotangent theta. And then I notice the cosines are going to cancel, but there's only 1 on the bottom and 2 on the top. What is cosine theta over sine theta? Oh yeah, that's cotangent theta. So in the end, we are verified. The left side did equal the right side.